Hi everybody, here's just a quick refresher on our exponent rules that we had in the fall. First thing is, when we multiply, we add. Multiply, we add. That's the MA. For example, 3 squared times 3 to the 4th would equal 3 to the 6th. When we say multiply, we add, that means if we have the same base, the base here being 3, and I'm multiplying, I keep the base, 3, and I add the exponents. Another rule we have is when we're dividing like bases, we subtract. Divide like bases, we subtract, referring to the exponents. For example, if I happen to have 7 to the 5th divided by 7 to the 3rd, I have the same base, so I keep the base, 7, and I subtract my exponents. I would do 5 minus 3, which is 2, 7 squared. If I wanted to evaluate that, I would do 7 times 7. But for right now, I'm going to leave it in exponent form. The next rule we have is power to power, we multiply. What that means, if I happen to have a power, such as 5 cubed, raised to another power, squared, that would mean 5 cubed times 5 cubed. Well, the shortcut of that would be to multiply the exponents. So that ends up being, as a shortcut, 5 to the 6th power. If I wanted to evaluate that, I would use my calculator because that would get fairly large. Another example of that, I'll go up here to the right. Let's say I had parentheses, 3a squared, b, that's a 2, all of that being cubed. Well, that's a power to a power. 3 actually has a 1. That gets multiplied by the 3. The 2 gets multiplied by the 3. And the b, having a 1, gets multiplied by the 3. The end result being 3 cubed, a to the 6th, b to the 3rd. Remember, power to power, we multiply. Another rule we have to keep in mind, let's divide here. Completely different rule is that we don't leave negative exponents in our answer. For instance, if we happen to have 4 to the negative 2nd as our answer, we can't leave an unhappy exponent. We have to remember that that unhappy exponent, the negative 2, is there telling us it doesn't belong there. So we write that as 1 over 4 squared. And if I wanted to evaluate that, that would actually be 1 over 16, if I didn't want to leave it in exponent form. If I happen to have b cubed over b to the 7th, and I was asked to simplify that, well, I could use my subtraction rule and do 3 minus 7, because when I divide, we subtract. When I have the same base, I divide. When I divide, I subtract. That means I would end up doing 3 minus 7 after keeping the base b. So I'd have b to the negative 4th. I can't leave a negative exponent. So this answer would actually be 1 over b to the positive 4th. Once I move it down to the denominator, it becomes a positive exponent, because then it's happy. Let's turn the page and do one more example. Another example would be, let's say I have m to the negative 5th divided by m to the negative 8. Now both of these are negative, so both of them need to move somewhere else. The negative 8 is unhappy, it needs to move to the top. And the negative 5 is unhappy, it needs to move to the bottom. So let's do that first. I'll move the 8 up, that becomes m to the positive 8 up here. And I'm going to move the 5 down, that becomes positive 5 here. It looks much nicer. Now I need to apply my rules that says when I divide like bases, I subtract the exponents. So now I need to do 8 minus 5, leaving me with the same base m to the 3rd. And that's my answer. I hope this refresher helped. Rewatch it if you need to.